All right, so good morning, and in some cases, good afternoon to everybody. I think we're going to kick off. So, firstly, I'd like to just welcome everybody on the call. Um, Thank you for joining us. I'd like to just introduce you quickly to our panelists. My name is Graham Welton, and from the Flow team, I have Lenny Smith, who will be giving us a demo shortly, and I have Clarice on our marketing side. Also, a very special guest panelist today is Jeff Knepper from Canary. Jeff, thank you very much for joining us, and please feel free to answer any questions that might be directed to you. In terms of agenda, everyone, we're going to go through a couple of slides quickly, and then we're going to do a demo. We won't be able to demo everything, but we'll show you a few important points relating to Flow. And then we'll have a bit of a question and answer session for the last 10 minutes, hopefully. All right, so let's get straight into it. I'm sure a lot of you are asking what Flow is all about. And we like to explain it like this. So first of all, Flow is an information consolidation platform. So what do we mean by that? Well, Flow essentially gathers data from multiple disparate data sources, consolidates it, contextualizes it, stores it in a structure that's easily accessible and can be shared out as a single version of the truth. And why do we do it? Well, the main reason is, of course, to support decision making, which can extend from the shop floor all the way up to the boardroom. Let's just unpack a couple of points a bit further. Firstly, the data that we collect in the Flow information platform is transformed, it's contextualized, we can perform calculations on it to create calculated KPIs, and we can evaluate that information against limits or targets. One of the biggest components of Flow is the visualization component. And this is essentially a browser-based charting and dashboarding component. And now that you've got the single version of the truth, this is your data, and we've gone to great lengths to make it really easy to share that data out. So we have notification services which allow you to send information out in the form of messages through various messaging platforms. We allow you to integrate that data out into other systems. So maybe your ERP systems or your machine learning systems or your business intelligence systems, for example. So that in a nutshell is what Flow is all about. And I hope that we can show you a lot of these features in our next hour. I thought I would just touch on the industry verticals that we kind of perform in. These are a couple of the highlights. And the point here is that Flow is a very generic tool. It can be used across many different industries. And I've put in a couple of our bigger customers that you might recognize. These are more global manufacturing customers in various industries. And I'm pretty sure that you would recognize some of those. Okay, so in the next couple of slides, I actually want to highlight a few features in the visualization component. Now, the visualization component is only one component of the information platform, but it is the component that people see most often and interact with. So let me take you through a couple of examples. And I think just also to highlight that for this webinar, we've chosen the oil and gas industry as our example. Okay, so first example, you can see the dashboards are made up of panels. This is all HTML5. Here I'm highlighting scatter plots. One of the features of our scatter plots is you can actually create a profile or an overlay, which you can then actually ring fence a sweet spot for operating parameters, depending on what you are showing. We have various forms of charts, typical kind of stacking, multi-axis, etc. We have very simple widgets if you just want to put up a number with some information on it. But more complex widgets, gauges and donuts, for example. Many people like to see their data in a tabular format. So we've gone to great lengths to create visually appealing tabular data. You can apply formatting like heat maps, which just allow you to see where your KPIs are performing well versus where they're performing poorly. Another feature is that we use color a lot to show when limits are exceeded or when targets are achieved. And I'll highlight that a little bit later. We can also very easily add in spark lines or spark columns, if you will. Here's an example of where an exception is displayed in the form of color. So we overlay color when something has not achieved a target. So in this case, we've got a month-to-date accumulation of our production. And for those few days that are now shown in red, they haven't achieved the target for the month. We can apply various forms of regression to the charts. And this is really powerful because it gives you a best fit trend line, which in a sense gives you a bit of a prediction of where you are going to end up if you continue the way you are. And this is incredibly powerful to share with your operators as well as with your executives. Another very key component of Flow is that we can actually project data points into the future. And think of a production plan. We always plan into the future. Well, the beauty is you can bring those plans as projections into the future straight into Flow, and you can plot them against your actuals. This one is not a plan. This is actually a 7-day moving average, which has been projected into the future. And you can actually see how closely it correlates with the regression line. Here's an interesting one. Within Flow, you can effectively monitor for event frames. So Flow will monitor your raw tags in your Canary historian and pick up when an event has started, when it has ended. And more than that, it can actually attach additional context to that event. So, for example, we're using the event frames here to monitor downtime on a machine. But we're also picking up information about why that machine is in downtime. And certain of this information can actually be captured manually as well. Here we're presenting the events in the form of a Gantt chart. And here we're presenting the attributed value in the form of Pareto charts.
I found this on the web.
I want to bring this one panel here into focus. And what's interesting about this panel, if you look closely, this is actually a form that allows operators to enter data. So what we are doing here is we are actually capturing the event frames automatically, but then we are asking our operators through the drop downs, just like you would in a spreadsheet, to go and allocate various forms of information or attributes against that event. So again, this is incredibly powerful right inside your browser. Okay, so let me quickly take you through how the information platform works. So in the center here, we have an installation of the information platform. The first step is to connect to and collect your data from your data sources. So here I have a Canary historian, and the beauty is for most of you in our audience today, you probably have already invested in your Canary historian, and you probably have a couple of years worth of data. Now what you can do is you can actually connect that into Flow, and Flow can go back in time and pull a lot of that information and create KPIs for you directly in the Flow information platform. So you can leverage that investment that you have already made. The other thing is that if you haven't migrated your old historians to Canary historians, that's okay, because we can connect to other historians that are out there. We also have SQL-based data sources. So you can connect to Microsoft SQL, MySQL, Postgre, Oracle. We have IoT and cloud-based platforms that we can connect to. And lastly, we have the ability to create these manual entry forms which allow you to enter manually captured data. Now, we call these our data sources, and we have a whole bunch of them. The next step is to use our calculation engine. We call it our KPI calculation engine. That allows you to take this data that's either been collected automatically or manually entered and perform powerful calculations on that data. And one point to highlight here is that you can actually bridge those calculations across multiple data sources. So you might have a plan that you're picking up out of a SQL database, and you have your actual coming out of your Canary historian. You can do a KPI calculation which correlates your actual against your plan, if you will. The next step is to visualize, and I've shown you a couple of examples of that. This is HTML5, can be shown on big screens in production halls. It can be used on your laptop or on your projector in meetings. It can be used on your tablets, for example, wherever you have a browser that can access your Flow server. We have what we call our notification system, and this allows you to send messages out via various messaging systems. Email is one, Flow mobile app, Slack is another. And the beauty of using these messaging systems is that you're now bringing the people component into your decision-making processes, and hence the collaboration of bringing your information from your Flow system and the people together. Then the last layer of the Flow information platform is our integration component. And again, I stress, we've gone to great lengths to make it very easy to push your KPI information out of the Flow information platform to your other systems. And that might be an ERP, it might be another SQL system, it might be your BI or your machine learning. It might even be via MQTT Spark Plug B straight back into Canary. So you might be doing some calculations from a SQL data source that you want to get as a KPI straight back into Canary. Well, you can do that with the MQTT data consumer. You might want to use the MQTT data consumer to send data straight back to your SCADA system, if it supports Spark Plug B. And then the last one there is Flow. So the ability of being able to tier multiple Flow systems is used quite a lot by our customers, especially the multi-site companies where they have many sites having a tier 1 Flow system, and they aggregate that data up into a tier 2 Flow system at their head office. Okay, so that's the big picture of how it works. I want to touch on an aspect that you might be questioning, and that is specifically to the dashboarding component of Axiom in Canary and the Flow visualization in Flow. So it's a small component of the two products, but let me just touch on this topic very quickly. So, for example, Axiom dashboards, the way I like to refer to it, you've got really high resolution data, real-time information, which you can often live stream into your dashboards. You can do overlays of potentially alarm information. You can even build out mimics. So you can create this incredibly rich, live, high-resolution dashboard. Now, I want to explain what Flow does with this data. So for a specific time period, and let's assume that this is an hour time bucket, what Flow will do is it'll look at a single tag, and in Canary, you've probably got for that 1 hour, for that one tag, you've got roughly 3,600 points if we're collecting data at 1 second resolution. What Flow is going to do, Flow is going to take all of those data points, it's going to apply an aggregation method of your choice, and it's going to store a single value for that hour time period, a single aggregated value. And that is the value that gets stored and versioned in the Flow information platform. And that point for that hour becomes the single version of the truth. Okay, so this is quite an important concept to understand the difference between what Flow is doing and what Canary Axiom is doing. So to summarize, Flow dashboards, much lower resolution. The smallest time bucket we do is a 5-minute time bucket, but that can be aggregated up to an hour, to a shift, to a day, a week, a month, a quarter, and then a year. So we're looking at larger time intervals, typically showing KPIs over much bigger time intervals to support decision making. We do have the ability to overlay color for exceptions. And of course, the Flow dashboards, as I've shown, also allow you to have data entry forms. So if I were to really simplify this and try and help you understand the difference between Axiom and Flow dashboards, it is that Axiom is very much a real-time system, real-time dashboards, and Flow is historical dashboards. And the beauty of the two systems is that because they are both HTML5, you can intermix the two together, which is a great feature when you want to show something live, but you also want to show some KPIs from a historical perspective. Okay, so at this point, I'm going to ask Clarice just to throw up a poll, if you wouldn't mind answering a couple of questions while Lenny gets ready for the demo.
Perfect. Thanks, Graham. While we wait for the poll to get answered by our attendees, I've just switched over the screen sharing to my screen, and I'll take over from here. Clarice, how we are looking at the poll?
We are almost done, Lenny. Just give us some 10 seconds, if you don't mind.
Okay, cool. I think while we're busy with the poll, I'm going to start just explaining a little bit what I'm going to demo, and I'm going to extend Graham's explanation of real-time versus historical KPIs and dashboarding. I think for the start, some of us are ending our days, some of us are starting our days. So maybe a quote is in order, but in essence, all that the quote says is that if you don't know where you're coming from, you've got no idea where you actually are going. I think that's very relevant to historical data and what we can actually achieve with historical data when we start wanting to do potentially regression analysis and projections into the future. And this is exactly what Flow kind of achieves with that. Now, the best way that I kind of explain this concept is I look at a dashboard that we are all familiar with, and that we all understand very well, and that is a dashboard of a car. Now, my first car was a 1980 Toyota Camry, and it had a very simple dashboard. But the beauty of a car's dashboard is that it is simple, it is intuitive, it delivers information instantly. And I think it's still up to now one of the better ways of actually displaying data. But there's a problem. First of all, I've got my fuel gauge. Now the fuel gauge is connected to my fuel tank. And I've got my speed, and that is connected to my gearbox. Now the problem with that is, especially in 1980, this is two sets of information that's completely siloed with one another. So if I want to go and ask a question like, how far can I drive until I see the fuel light comes on, until I need to refuel? Well, the only way to actually do that with the data in isolation of one another is with experience. So you know this car, you've been driving this car for quite a long time, so you know how long and how far you can still drive it. Now, luckily I've upgraded, so we're going to skip a few years into the future to the year 2000. And my new Toyota Camry now has what we call an ECU. And the great thing about an ECU is that now all of that data points is connected to that ECU. So it becomes, in essence, my platform that I've got. Now the data is not in isolation anymore. Now I can actually apply context to the data. Although it's two different sources of the data, I can now actually look at them together. And I can now create a KPI that tells me how much fuel is left in the tank in conjunction with what the actual speed is that I'm traveling at. Perfect. But there's still a catch. When we look at the speed that I'm traveling in, that might differ. So I might be cruising around on the highway, I might be doing 80 miles an hour, cruising along, and then all of a sudden I get a phone call from my mother-in-law, and I need to pick her up to go for do some shopping. And all of a sudden I speed up. I hit the accelerator button. Obviously, I love my mother-in-law, so I want to get quickly to her to pick her up for do some shopping. The problem with this is now, if I look at this value in isolation, and I'm driving at 140 miles an hour, I might think of the fuel that I've got left in the tank and say, you know what, I've only got 2 miles left, and then I need to go and fill up with petrol or with gasoline. Well, the same is true if you suddenly see your dog Fluffy in the driveway and you hit on the brakes, and all of a sudden you're almost to a complete stop. Now, if I look at that value in isolation, well, technically I can go and drive up until infinity because I am at a very low speed and I'm not taking all the data points in consideration. And technically I can win the Nobel Peace Prize because I've just figured out how to solve our carbon emission problem that we have with greenhouse gases, because I can travel as far as I want with all the fuel I've got left in my tank. So obviously we cannot look at these values in isolation as the real-time values as they come in. So what we need to do is we obviously need to aggregate the data, and we need to clean it. We need to apply aggregation to the data or aggregations to the data. In this case, a very simple average aggregation on the raw data that's been stored in my historian will clean out all of these little outliners that I have so that I can actually make an informed decision of where I'm heading. And this is why we love historians, right? Because they store all of this raw data. They give us all of this raw, high precision data that we can actually go and apply these aggregation methods on top of it. Now, obviously, if I look at my tank or my fuel in my tank, it's not just good and well, I look at the current level. I also need to do an aggregation on that. So I need to look at the delta. So how much fuel has left my tank in, let's say, the past 5 minutes or 10 minutes, etc. So it's very important for us to create these aggregated methods on top of the raw data that we get so they can get to these answers. And now, if I've done that, I can actually replace my experience with an actual KPI that's automatically calculated for me that tells me how much range do I have left before I need to fill up. And there's another thing that we can also do is, because at this point in time, your mother-in-law is probably going to phone you and she's going to say, how long are you still going to be until you get to my house? So if we can share this data out to all the people that needs to see it, they can make their own decisions and see when will you actually be at a house to pick up. So that's just a way that I like to explain it, to just bridge that gap between what we can get from real-time data and what the power of historical data can give us when we actually build out KPIs, etc. All right, so let's get back into Flow itself, and let's see how that works on top of data that's actually now stored inside of my Canary historian. So I'm going to go and flip across here. So as Graham mentioned, this is, or as you've seen in the presentation, this is Axiom. So this is a typical kind of Axiom dashboard that I've created. And I've got all my assets on the screen here. I'm looking at oil wells. I can see what the current pressures are on the wells. I can see what my total outflow of this is. And I can also obviously browse to all of the different wells that I've got in my enterprise. So that's great. So I've got my real-time data here from an Axiom perspective. But let's now take and apply aggregation on top of that and potentially mix that with other data sources to see what type of dashboarding I can build on top of this data here. So the first thing that I always, or the first thing that everybody would like to see is, okay, where's the money? Where's the buck? So am I meeting my targets? And that's been set out from a production perspective. So the first type of dashboard that I'm going to look at is my production dashboard. So what you see on the screen here is a few things. So I'm just going to explain to you guys all the little data points that we see on the screen here. So currently I can see what is my total production for the day. I can also mix that with what was my target for the day. And you'll notice that I am a little bit below my target. So my actual well production is below my target. Now this target can come from an ERP system. It can be fed in manually. It can be done from a finite scheduling solution. And at this point, when I'm looking at the dashboard, I don't really care where that information is coming from. The point is that I can contextualize this information from all of these different systems to give me this composite look and feel. Obviously, I've created a delta, so I can see what is the difference between my actual production and where my target is. So I'm a little bit below. So obviously, there's some stuff I need to look at to see if I can rectify what the problem here is. And I can also see from my 7-day moving average, I'm well below from where I normally are from an average perspective. So obviously something is up. This little widget that I've got at the bottom here, it's an area chart. What it shows us is that currently I am below my 7-day moving average. So the line there just represents the calculation that I've done on what is the moving 7-day average. And currently I'm well below of that. So obviously there's something wrong. At the table chart next to it, you can see that I've got a chart just showing me what is my daily production. And what I've also done on my daily production here is I've applied a regression analysis on top of that data. So clearly I can see that if I continue the way that I'm actually running my production at this point in time, I am going down in a downward spiral. So on Friday the 31 of July, luckily it's not Friday the 13th, but I will also almost go and have no production out of this well anymore. So obviously something is not right. Graham explained at the bottom here that we can also do projections, and we can also enter values for our projected targets for the month, and we can actually enter that in for the entire year. And what I've done at the bottom here is I've just showed that out. So I've projected this production to the end of the month. And at the end of the month, we can see potentially where I can end up with from a production perspective. So I've created this dashboard. I've applied some aggregation techniques on top of it, and I've visualized it on this perspective. So how easy and how quick is it to actually create these different aggregations and to clean the data? Well, if I go into the Flow configuration tool, so this is the actual configuration tool where I will go out and build out my aggregations. I'll just explain a little bit on what we see on the screen here. So the first thing that we see here is that I can go and create a model of my site or my enterprise. And the nice thing is about this model is it creates one contextualized model. Doesn't matter from which data source I'm getting my data. I can get my data from Canary, I can get it from a SQL database. It doesn't matter. I can create this one unified model of my production environment. And then obviously on top of that, I can go and spit out my different reporting that I can go and create. So we have two different models depending on the actual physical model of your enterprise versus the reporting model that we can go and configure there. And obviously I can go and connect this to a whole bunch of different data sources. So I've got the Canary historian connected. And as you can see, we go and browse the views of that historian. So I can see all the different tags that's available for me in that Canary historian. And if I double click on it, we will return the raw data so that you can just have a very brief understanding of what the data is looking like that you're going to aggregate or play with. We do not replicate this raw data. It stays in the Canary historian. We just pull that out and apply our aggregation techniques on top of that. But obviously, as we explained, we can go and connect to a whole bunch of these different silos of information and bring them into the flow system to add context and calculations to them. So we can connect obviously to the Canary historian, we can connect to the Ignition historian from inductive automation. From Microsoft, we can connect to SQL databases and Excel workbooks. Oracle, we can connect to MySQL and Oracle databases, PostgreSQL databases. Wonderware, we can connect to the different flavors of the Wonder historian. We also have a web services core that we can connect to. And for other historians that we don't have a native integration into, we can utilize either the OPC HDA or the OPC UA integration to get historical data out of those historians. And I can use all of those different data sources to create very complex and very meaningful KPIs. So let's quickly do that. I'm going to extend my model here. So currently in my model, I've got a production site. I've got all my different wells that I've modeled out. I've got my wells production, so all the flow rates in there. I've got the utilization of how much time this well has actually been in production. So I've mapped that out from a utilization perspective. But what I'm going to do is I'm just going to quickly go and extend this for my webinar here. I'm just going to call this folder webinar. So it's very easy to build out the model. And I'm going to go and create a flow metric in here. And what I want to now do is I want to go and clean and create an aggregation method on the data that's in my Canary. So all I have to do is take the tag that's in Canary, drag it across to my model, and this will automatically create a measure or a KPI point for me in Flow. Now, if I open it up, look at the retrieval section here. There's a whole bunch of different aggregation methods that we can apply to the data. In my example here, I'm just going to do a simple time-weighted average to tell me what is the total flow for the hour, but we could have selected min, max, counter. A very popular one for utilization is obviously time and state, if you want to start looking at utilization calculations as well. But for this example, I'm just going to do a simple average. I'm going to deploy it out, and the flow engine in the back end will go and query the raw data. It will apply this aggregation method on top of that raw data, and it will store the result inside of the Flow database. And if the next hour comes along and the next hour comes along, the Flow engine will keep on doing that automatically and keep this repository of us up to date. So if I refresh here, there we go. We ran through all of the historical data. We've created an hourly time bucket, and we are actually storing the values inside of our database or repository. Cool, and I can do exactly the same for another well. So let's very quickly create another flow for well number 2. And I'm going to deploy that out as well. Now, if I want to know what is the total between flow 1 and flow 2, then obviously I can very simple drag this onto this little calculator icon here. This will now be my total flow. And I can go and create this calculation. In this example, it's a very simple calculation where I simply can go and add the two flows together. So I can go and add flow 1, add flow 2, verify my calculation, and deploy it out. From that perspective, we will add the two results together, and we will store the result inside of the database. We can also backfill, so you'll notice I'm backfilling data all the way till the 5th of the month of May. So if there's already historical data in these sources, we can use that to already create historical KPIs on top of that. So there's my total flow created and calculated. I can also very simple do roll-ups. So if I want to know what is the total for the shift, I literally go and drag it onto my hourly icon again. What this will do, it will do a progression or a shift to date total automatically. If I drag it again, we'll do a day to date. And if I want to potentially show a daily value, I can literally just drag it onto the daily icon here. And I now know a sum of my daily production that I've got, and I can deploy these out, and the Flow engine will do that in the back end as well. All right, so that's how easy it is to clean the data. But I've actually done a cardinal sin when I looked at my dashboard here, because I was talking about looking at data not in isolation of one another, but looking at data in context. But what I'm looking at the screen here is just production. I'm just looking at the outflow of my wells. But I want to know, in context to potentially other parameters, how's my well performing? So what about putting that in context to potentially the pressures? So in this case, I'm utilizing my scatter plot. And what I'm doing with my scatter plot is I'm using the flow rate as the base axis, and I'm plotting it in conjunction to my pressure. All right, so now I've got a point where I can see how well am I performing, depending on how well I've tuned this well and how well am I actually to the profile curve, or where I should be actually running this well. Now you'll notice that the last value is highlighted by the value there, 125. It's not too close to the nominal point where I would like to operate. It's actually drifting a little bit away from where I would like to operate this well. So potentially, this is why I'm not getting the flow out of my well. So putting data into context to one another is great to actually go and see where potential problems are. So we should start looking at data in context. Now, how did I actually go and create this scatter plot? Again, if I look in the configuration tool, I do have a pressure as well. So I can very simple take that pressure, I can drag it across. Maybe I should create a new metric for that. So this will be my pressure metric. And I can simply drag the pressure tag across, deploy it out, and now I can use that metric in potentially to create a chart or a scatter plot. So I'm going to go to my reporting section. My reporting section is where I actually build out my reports and charts and dashboards. And I'm just going to extend it here with a new little folder here just to separate this. So this is my webinar folder. And in here, I can actually go and create a whole bunch of different charts. So all of the different charting that you've seen that we've presented before, we can go and select from here. All the way from bullet charts, comment charts, event-based tables, timeline charts, heat maps, map integration, Pareto charts when we start looking at downtime analysis of OEE. In this case, I want to use potentially the scatter chart. So I'm going to create an hourly scatter chart here for me. And all I have to do in the scatter chart is to configure the base axes. So in this case, I want to use flow as my base axis. So I'm going to use the flow measure as my base axis. And then I'm going to add the tubing pressure as the axis that I want to go and validate it against. I can select how much data points do I actually want to show on this chart. So potentially I just want to show for the last 7 days of data. And that's it. I've configured a scatter chart with the base axis as the flow and the tubing pressure as the corresponding correlation that I want to see. So if I refresh my dashboard here, I should have a new folder that I can select from, and that folder should now be my webinar folder. And underneath my webinar folder, I will have my scatter plot, and I can now go and show my scatter plot on the screen. I've got a very little data set here, but there you guys can see how quick and easy it is to actually go and create a scatter plot chart with that correlation. And we can add, obviously, as we've seen, the profile curve to it as well. So it's very simple and easy to go and create that. All right, so if we go back from my scatter plot dashboard, obviously I can see that there's definitely something wrong with my individual well itself. So maybe I need to go and investigate why my well is not well. So well, that's a great start of the day, why my well is not well. Anyway, so let's go to well number 1. So this is a more deep dive session into the well itself. And what I can see from this is that there's some downtime booked against this well. So you'll notice that I've got a manually entered form that can now give me different context against this well. So now I'm adding not just context from historians or from data sources. I could have, if I could have figured out if the well is standing from a tag or a point in a maintenance database or NES database, or from the historian itself. But in this case, I can actually book downtime classifications against this well manually. So I can go here and add a new downtime classification. I can say when I want to end it. I can say when the downtime actually started. So this started on the 14th. I want to end it now, and I can go and change the duration of this downtime event. And I can book this downtime event against this well asset. Now, obviously, I can book it against a specific department. So I can go and maybe book it against scheduled maintenance, scheduled production, unscheduled maintenance, etc. So maybe this was an unscheduled maintenance request. You'll notice that we populate these boxes from what you are allowed to tick. And we can control what is the actual fields that you can select from when we go and select these components. And I'll show you that in the configuration tool as well. So we can go and do these classifications against a piece of equipment. We can also go and see what is the actual time that this piece of equipment is in a producing state. In this case, I've just utilized the normal time and state retrieval method to see how long has this piece of equipment been running in a day. And for the past day, I've only been utilizing or running this piece of equipment for 21 hours. Again, I've applied regression analysis on normal, just very simple linear regression analysis on the data for how long am I running my well. And from the chart here, it seems that this well is giving me more and more downtime as I go on. So it seems that I'm getting less and less utilization out of the actual production out of this piece of equipment. Again, we utilize the manual data that we've collected here, and we can visualize that into different contexts. In this case, I'm utilizing our Pareto capability to show you what is the ratios between scheduled maintenance, unscheduled maintenance, etc., from a normal kind of OEE or utilization perspective as well. So that's just an idea that I can show you guys a little bit more deep dive dialed into the well itself. What I can also do here is to say, you know what, for this particular downtime event that I've classified against my piece of equipment, there might be some other metadata that I would like to associate with it. So I've got some additional columns here that I want to potentially add. So potentially I want to add how much barrels were lost, as an example, due to this downtime event. So I can go and enable that, show that column, and now the operator can maybe tell me if it's by hand or manual, or if we had the rates, we could probably have worked it out. But in this case, I would like the operator to tell me how much barrels that we lose in this case, and I can go and add that in from that perspective. We also have the capability to create time-based forms. So we spoke about adding your projections for the month. And I've got a very simple form here where I can now add what is the theoretical production of my well versus the actual production that I'm getting back from the historian. And we can also give this manual capability to our operators to see and to add our targets, to add our production schedules, etc. And we can do this into the future, as Graham explained. Now you'll notice a few things here. You'll notice there's some red dots, there's some yellow dots, there's some triangles there. And what this all shows us is red dots, first of all, tells us, is the data that we're getting back from our historian good? So we flag the OPC quality data from our historians. Notice that we always version control the data that gets into Flow. A yellow dot means I've changed the value. So if I double click on that, you'll notice that I've logged in and I've changed some values manually, and we keep track of all of these little manual data corrections. So truly we can say that we are the single source of data, and there's a full-on audit trail all the values that's already been stored inside of the flow in the flow system. And obviously, if it's got a little yellow or a triangle with it, that's just to show you that it's breached a limit condition. So while the operators and while your production people are capturing data, we can already do limit evaluations to tell them, are we below or above set point. Just to show you guys from a configuration perspective, when we build out these matrices or groups from what we can select from a downtime perspective, we've got this classification concept here where we can build up these matrices of what the operators are actually allowed to select, to actually go and specify. If I selected schedule maintenance, these are the disciplines and the equipment and the location that I can select from. And with that configuration, we will obviously go and populate all the options that's available for us here to actually do our downtime allocation. I've demoed it that it can be done by hand or manual. Obviously, if we have data in the historian, if we have data in our MES databases, we potentially could have pulled out this metadata or this additional context automatically against this stop event that we've got on my well as well. Cool. Now, Graham also mentioned that this is both HTML5 technologies. So I can potentially go into my Canary Axiom dashboard here. I can click on this pressure screen here, and I can actually show that pressure or scatter plot chart that I've configured right here inside of Axiom. So now I can mix and match my historical KPIs that I've created, my context that I've added against potentially different measures or KPI or different data sources inside of the same environment where I can now obviously look at my trending, my raw value trending from an engineering analysis perspective. I could have potentially done it the other way as well. Flow is also a source or a host. We do have the capability to embed a web page of a different system in here. So I could have just as well went into Flow and embedded an Axiom dashboard. And the user or the user experience that we get is exactly the same. It's almost like you don't even know that you're looking at two different systems when you do start embedding it from that perspective. Last thing before I end off for questions is I've ended up my slides where I said that your mother-in-law is phoning you to tell you, listen, how far are you away from actually picking me up? So obviously, I would love to share this information with her. She doesn't phone me. And with that, Flow has the capability of what we call notification engines. So we've got a concept where we can go and configure messaging. And we've got a whole bunch of different ways that we can notify the user. We've got our own mobile app, as you saw from the presentation we've done a little bit earlier. We can send details through email, Slack. We can do a file drop to a shared FTP location of an actual dashboard. We can do bulk SMS or Twilio SMS if we still need to send an SMS. So what I've done for this demo is I've just created a channel where I would actually send it to Slack. So I can get some Slack integration going here and I can send my messages out. I've got an engineering message here that I've configured. So if I open that up, I can say, when do I want to send the message? So in this case, what I'm sending is I'm saying at the end of the day, we can go and send out this message. And we can configure what that end of day means because Flow is calendar aware. And I can, from a contents perspective, say, okay, you know what? I would like to send that entire pressure dashboard to my channel. And I can also say to which notification service do I want to actually send it. In this case, I'm sending it to Slack. And in Slack, I've got a very specific channel that I'm sending it with. So I can go and configure. The nice thing about this is I potentially can send it to Slack, as well as email, as well as the Flow mobile, the same message, the same content, and deliver that to all three of those notification servers. So now we have to wait until the end of the day before we get the message. Luckily not. I can go and trigger the message manually. So I've just done that a little bit earlier. So it's busy compiling the message. And hopefully very soon we will see that message being compiled, the dashboard rendered, and actually being sent out to my Slack channel. So while we're waiting for that, I hope I haven't gone too fast. Sorry, I tend to do that a little bit, go a little bit fast in these demos. But I hope that gave you guys an idea of how easy it is to create context between different data, being manual, being from historians, being from other data sources, how I can create these KPIs, marry that with my dashboard. I think my Slack message just came through, so I'm just going to go here to Slack. There we go. So there's my Slack channel, my flow test. There's my little dashboard that I've created, and I've sent that out to my Slack channel, and I can see that actual dashboard right there and there in my Slack message, so we can actually deliver the content to wherever you are, and you can see that details. With that, I am pretty much done. Graham, I'm going to hand back to you.
Well, thank you very much, Lenny. Just to finish off before we get to maybe a couple more questions, can you present on your presentation the license model for me?
Perfect. There we go.
Okay, so I thought it would be useful just to talk about the licensing model. We have a very simple licensing model. It's the flow information platform is licensed by system effectively. So let me talk through our perpetual licensing model. So effectively a once-off plus a 15% per annum for maintenance. The system comes with unlimited users, unlimited charts and dashboards, unlimited clients, 100 measures or KPIs, and 10 event definitions. So that's what you get in your base system. Then, similar to how you can just add tags to your Canary historian, Flow allows you to add additional measures as and when you need to. And those would be $5 per measure. And event definitions you can add as and when you need additional ones. And those are $50 per event definition. We do also offer a subscription model. You can see the numbers there in the grayed out format. But effectively, what we like to do is we like our customers to start small with a small investment, make sure that what Flow is offering them is what they are looking for, and then grow their systems as they need to, and hence this licensing model. And as a special discount at this stage, what we are offering to all Canary customers, we are offering a 15% discount to get you guys to start leveraging that Canary historian data with a Flow system. So up until the end of September this year, you will qualify for a 15% discount. So please shout and we can get you going on that as soon as possible. Okay, we have had a number of questions. We've tried to answer them in the Q&A section as we were going, just in case we ran out of time. But I think what I'd like to do is just pick on a few of the questions, just to talk through them, because some of them were quite key.
Cool. Great.
Okay.
So,
yeah.
Just maybe before we do that, I don't know, Clarice, did you share the results of the poll as yet? There we go. All right. So just maybe before we go into Q&A, most of you guys say that the top 3 biggest information challenges is actually to have self-service reporting and analysis. And I really hope that you've seen from the Axiom tools and then from the Flow system that we can definitely give you self-service reporting and analysis capability. Sorry, Graham. Over to the questions.
Perfect. Thanks, Lenny. I see the other one there is reporting and analyzing across multiple systems. And I also think that you've hopefully seen that is actually core to the functionality of the Flow information platform. Okay, so we've got 5 minutes, guys. Let's go through a couple of questions. Jake asked, is the manual entry stored in the historian database, or can you write back to SQL? So Jake, the Flow Information Platform actually uses a Microsoft SQL database as its repository. So any manually entered data actually gets inserted into the Flow database. So we don't believe in writing back to the historians. We don't want to mess with the single version of the truth within a historian system. Within the Flow system, any data that you write into it, even if you are retrospectively updating a KPI that's come from a historian, which Flow allows you to do, Flow keeps a version and a history of every single data point. So we like to keep that within the Flow system. Further to this, if you do want to, and I may not have understood your question correctly, but if you did want to write back to another SQL database, which you may have for other reporting or whatever, absolutely you can use Flow with its integration component to automatically push any KPIs values, whether they're retrieved, whether they're manually entered, any of them, you can push them out to any SQL database. I see we have an open question, so I'm going to run to that one first. What is 15% PA? So James, that is a 15% per annum maintenance charge. If you want to remain on support, it's not compulsory, but if you want to keep up to date with the latest releases, it's a typical software annual maintenance. So I hope I've answered that question. Okay, let's have a look at some others. Is there a native connection to Ignition? Yes. If you want to push your KPI information or your calculations out to Ignition or any other SCADA platform that uses Sparkplug B on the MQTT protocol, yes, you can send that information, and the Flow integration layer will automatically send that data as soon as it is retrieved from a historian or manually entered or calculated. As soon as that data is calculated or available in Flow, it can push it out to your SCADA systems via MQTT using the Sparkplug B protocol. Right. A question from Felissa: can mass, energy, VLE balances be performed in Flow? So it's a difficult question to answer, Felissa, but I'd like to say that you can. Flow can handle fairly complicated calculations because it uses C# syntax. And C# on the .NET platform has a number of good solver libraries. So I believe that you probably could do most of what you'd like to do directly within Flow. We would certainly recommend that that is the first pass that you take to try and keep all of your information within the one Flow system. We also have the ability, talking about calculations, we have the ability for our customers and system integrators to compile their own C# libraries for use with our calculation engine. So if you want to protect your IP or you need to do something really complicated, you potentially could build your own calculation library and import that into Flow. And we would certainly assist you with that. Okay, so I think that pretty much covers everything. I'd like to just finalize the webinar by thanking everybody. And thank you to Jeff for joining us as well. Thank you to Jeff for inviting your customers to our webinar. Please contact us if you have any further questions. Have a look at our website. Get in touch with us if you have any require any further information. Thank you to Lenny and Clarice. Great demo, Lenny. And we'll hopefully hear from you soon. Thank you very much, everyone. Goodbye.
Awesome. Thanks, Graham. Awesome. Thanks, guys. Enjoy the rest of your days. Cheers.